We are going to learn one important chapter, that is factor theorem and remainder theorem. Now, before going to learn this chapter, after learning this chapter, we shall see what are the learning outcomes. So now I am going to write down all the learning outcomes. First point is polynomial. Second point is degree of a polynomial. Then third is terms of a polynomial. Terms of a polynomial. Then coefficient of their terms. Then types of polynomials, factors, multiples, polynomial equations, value of a polynomial, then roots of a polynomial, then various notations of denoting the polynomials. Then exponents of a variable, division algorithm, then remainder theorem, factor theorem, hit and trial method of getting factors of a polynomial. Illustrations. Daily life applications. So, in this chapter, these are the learning outcomes: polynomial, degree of a polynomial, terms of a polynomial, coefficient of the terms, types of polynomials, factors, multiples, polynomial equations, value of a polynomial. Then roots of a polynomial, various notations of denoting the polynomials, exponents of a variable, division algorithm, remainder theorem, factor theorem, hit and trial method, getting factors of a polynomial, illustrated examples, and daily life applications. Now we shall learn what is a polynomial. An expression of the form, an expression of the form a naught x to the power of n plus a1 x to the power of n minus 1 plus a2 x to the power of n minus 2 plus etc. plus an minus 1 x to the power of 1 plus an, where a naught, a1, a2, etc. an minus 1, an belongs to R. R means set of real numbers. These are all the real numbers. Now, and n is a non-negative integer. Is called a polynomial. Is called a polynomial in the variable x. This is the definition of the polynomial. So it is an expression. So what is a polynomial? It is an expression of this form. This is the form. A naught into is understood. A naught x to the power of n plus a1 x to the power of n minus 1 plus a2 x to the power of n minus 2 plus etc. plus an minus 1 x to the power of 1 plus an, where a naught, a1, a2, an minus 1, an belongs to real numbers, and n is a non-negative integer. Be very careful. We are using the word non-negative integer. We are not saying it is positive integer. It is non-negative integer. Is called a polynomial. This expression is called a polynomial in the variable x. This is important. Whenever we say it is a polynomial, in which variable is most important. The polynomials in the variable x are usually denoted by fx, gx, hx, etc. We already learned an expression. So a naught x to the power of n plus a1 x to the power of n minus 1 plus a2 x to the power of n minus 2 plus a n minus 1 x to the power of 1 plus an. This is a polynomial, and we denote this polynomial with fx or function of x. So simply fx you can read. Fx is equal to a naught x to the power of n plus a1 x to the power of n minus 1 plus a2 x to the power of n minus 2 plus etc. an minus 1 x power n plus an. So this is the notation you can also take, instead of fx, you can also write gx. Similarly, you can write it as hx. It is a polynomial in variable x. Now, we shall learn some of the important properties connected with the polynomials. First one is condition and degree. This is the first point. And the second point is constant term. And the third point is coefficient. And the next point is leading term. Leading term and its coefficient. Then zero polynomial. Last one is constant polynomial. Now we shall study one by one. Condition and degree. All of you know this is a polynomial. Here we have already discussed a0, a1, a2, an minus 1, an belongs to real numbers. The condition is, so a0 should not be equal to 0. This a0 should not be 0. If it is like this, we say the degree of the polynomial fx is n. We say the degree is n. Constant term. Now, these are all the terms. Observe the last term is called as constant term. So, the constant term is an. Then, coefficients. What is the coefficient of x to the power of n? It is a0. Then, coefficient of x to the power of n minus 1 is a1. Coefficient of x to the power of n minus 2 is a2, etc. Coefficient of x is an minus 1. These are all the coefficients of the terms. The first term, second term, third term, like that. Now, next one is leading term and its coefficient. Always this is called as the leading term. Means the highest power is the leading term and its coefficient. So the term is a0 x to the power of n and the coefficient means its coefficient. It means leading term coefficient is a0. So a0 is the leading term coefficient. See, we already discussed. See, a0 not equal to 0. Then, zero polynomial. What do you mean by zero polynomial? See, fx is equal to 0. So, zero polynomial, its degree is undefined. This is very, very important. If the polynomial is zero polynomial, its degree is undefined or not defined. Now, we can't tell its degree. Now, constant polynomial. What do you mean by constant polynomial? Means fx is equal to c, where c is a constant. Now, for a constant polynomial, its degree is 0. The constant polynomial fx is equal to c, its degree is 0. Now just I am going to summarize. So notations. So this is called as notation. Polynomials are denoted by fx, gx, hx, etc. Let us take fx is equal to the polynomial. So now the condition is your a0 should not be equal to 0. Then we say it is a polynomial of degree n with variable x, and it is denoted by fx. Constant term. This is the constant term. Term independent of x. It is also called as term independent of x. Now, coefficients. See, these are all the terms, and the coefficient of x to the power of n is a0. Coefficient of x to the power of n minus 1 is a1. Coefficient of x to the power of n minus 2 is a2, etc. Coefficient of x is an minus 1. Now, leading term and its coefficient. So, the highest power of the x is the leading term. A0 is the leading coefficient. So, it may be anywhere, even in between these two terms, here, somewhere here. So, you have to observe its power. Now, zero polynomial. If fx is denoted as 0, it is called a zero polynomial, and its degree is undefined or not defined. Then constant polynomial, fx is equal to c, its degree is 0. So far we have studied the definition of polynomial and its notation. After that, certain concepts related to the polynomial. Now, we shall go further, take the examples of a polynomial. Examples. First one, fx is equal to 0. He is a zero polynomial. Clearly, its degree is 0. Sorry, its degree is not defined. Second one, fx is equal to 5x plus 9 is a polynomial. Is a polynomial in x of degree 1. It is also called as linear polynomial. Linear polynomial. Its general form is fx is equal to ax plus b, where a and b are real numbers and a not equal to 0. Now, we shall take the third one. Now I will change the notation. Zx is equal to 3x square minus 5x plus root 2 is a polynomial. Is a polynomial in the variable x of degree 2. It is called as quadratic polynomial. Its general form is gx is equal to ax square plus bx plus c, where a, b, c are real numbers and a not equal to 0. Now we shall take fourth one. Now I'll take it as g of t. G of t. So 12 t cube minus 4 t square plus 70 minus 6 is a polynomial. Is a polynomial in the variable t of degree 3. It is called as cubic polynomial. Cubic polynomial. Its general form is gt is equal to a x cube plus bx square plus cx plus d, where a, b, c, d are real numbers and a not equal to 0. Now, 5x is equal to 7x to the power of 4 minus 3x square plus root 2x minus 2 by 3 is a polynomial in the variable x of degree 4. It is called as biquadratic polynomial or quartic polynomial, and its general form is given by 5x is equal to ax to the power of 4 plus bx cube plus cx square plus dx plus e, where a, b, c, d, e are real numbers and the leading term coefficient should not be equal to 0. Now, these are some of the examples. Fx is equal to 0 is a 0 polynomial. Clearly, its degree is not defined because it is 0. Now, second one is fx is equal to 5x plus 9 is a linear polynomial in x of degree 1. Here the leading term is 5x. Its power is 1 exponent and the coefficient of x to the power of 1 is 5. It is also called as linear polynomial and its general form is given by ax plus b where a not equal to 0. Now, third example is gx is equal to 3x square minus 5x plus root 2 is a polynomial in x of degree 2. Here, the leading term is 3x square. It is also called as a quadratic polynomial. It is denoted by the symbol gx, which is equal to ax square plus dx plus c, where a not equal to 0. Then gt is equal to 12t cube minus 4t square plus 7t minus 6 is a polynomial in the variable t of degree 3. So here the leading term is 12t cube and it is called as a cubic polynomial. It is denoted by general form is gt is equal to ax cube plus bx square plus cx plus d, where a not equal to 0. Then fifth one is 5x is equal to 7x to the power of 4 minus 3x square plus root 2x minus 2 by 3 is a polynomial in x of degree 4. Here the leading term is 7x to the power of 4 and it is called as biquadratic polynomial. Its general form is given by ax to the power of 4 plus bx cube plus cx square plus dx plus e, provided the leading term coefficient is not equal to 0. And the constant term in the first case is 9 and the constant term in the second case is root 2 and in the fourth case it is minus 6. In the fifth case it is minus 2 by 3. So these are all the terms of a polynomial. These two are, it's a binomial. It is a binomial. So then, so 1, 2, 3, 4. It's a multinomial. It's a multinomial. So in general, they are polynomials. So these are the important examples which strengthen our definition polynomial. Now one more example is there. That is example number 6. 7 is a polynomial of degree 0 because 7 is a constant. So we know the degree of the constant polynomial is 0. So we denote it by fx is equal to 7 in general. So we write fx is equal to c, where c is a constant and c not equal to 0. If c happens to be 0, if it will become not a constant polynomial, it becomes a 0 polynomial. Now, one important note. Now I am going to write one fx is equal to 7x cubed minus 2x squared plus 3x minus 4. This is a polynomial. Suppose if I write root 7, it is also a polynomial. Suppose if I write root x here, it is not a polynomial. Why? Because root x means x to the power of half. So this is a fraction. So the index or the exponent should not be a fraction. If it is a fraction, we say it is not a polynomial. Suppose if we write like this, it is not a polynomial. Even if this is correct. Suppose if I write 7x cubed minus 2x square plus, suppose if I write root 3x minus 4, this is a polynomial because here root is for variable, here the root is for a constant. So it is a polynomial. So when you are deciding whether it is a polynomial or not a polynomial, care should be given for the variable. This variable is most important. So it is not a polynomial. So this is a polynomial in x of degree 3. Suppose, now this is the leading term. This is the leading term. Suppose, now if I write to the power of 4, yes, now it is also a polynomial of degree 4, not 3. Highest power should be taken. So now this will become the leading term. This will become the leading term, not this. Because you have to see the power. Then only you have to decide it's a leading polynomial, leading term or not a leading term. That's all. This is an example for not a polynomial. If it is a polynomial, then it is what type of polynomial? It is linear polynomial, a constant polynomial, zero polynomial, quadratic polynomial, or biquadratic polynomial, etc. You have to classify it. So it is the first thing is you have to see whether it is a polynomial or not a polynomial. That is important. Now we shall write down some examples on polynomial equation. Polynomial equations. This is the first example. 3x square minus root 5x plus 7 is equal to 0 is a polynomial equation of degree 2. Now we will take one more example. 7x cubed minus 3x square plus 5x plus 11 is equal to 0 is a polynomial equation of degree 3. See what we are going to observe. One thing is, if you do not write this is equal to 0, this is going to become an expression, not an equation. we are using polynomial equation. So 3x square minus root 5x plus 7 is equal to 0. So 8 is equal to 0. Then it is a polynomial equation of degree 2. Here also 7x cube minus 3x square plus 5x plus 11 is equal to 0 is a polynomial equation of degree 3. This is the left hand side and this is the right hand side. So the degree is 3. The leading term is 3x square. Here the leading term is 7x cube. If you simply write like this, 3x square minus root 5x plus 7 is equal to fx. This is only an expression, polynomial, that's all. If you write instead of this, suppose if you write is equal to 0, then this will become a polynomial equation. Similarly, 7x cube minus 3x square plus 5x plus 11. This is only an expression, a polynomial, and it is denoted by gx in variable x of degree 3. And if you want to make this polynomial as an equation, you should equate it to 0 here, or you can equate it to 0 here. So these are the examples of polynomial equation. Be clear which is a polynomial expression and which is a polynomial equation. In equation, you will be having left hand side and right hand side. If you take this example, this is your LHS, left hand side. This is your RHS. If you write like this is your LHS, all this is your RHS. There will be two sides for an equation, whereas in an expression, only single expression will be there. That's the difference.